The string class is one of the most common complex classes you'll use in Java. The string class has a special characteristic. It's immutable. This means that when you set a value of a string object, that value cannot be changed. Now, it might seem like you can change it. Let's take some very simple code. I've declared a string called s1 and given it a value of welcome. I'll place the cursor on the next line and say s1 equals s1 plus 2 California. You could also write this code using the plus equals operator. Either way, it looks like you're appending to an existing value and simply changing the value of an existing variable. Then I'll output the value of that variable to the screen using system.out.println, and I'll pass in s1. And I'll run the application, and everything looks like it's working just fine. But it's not so great in the background. What's really happening is that when you append a value or otherwise change the value of a string variable, you're actually creating a new instance of the string class, and you're abandoning the reference to the old object. That old object is still out there in memory. It becomes eligible for garbage collection, but in fact you're using more memory than you need to or should. You won't see this behaviorally in your applications. The issue only becomes apparent when you're trying to tune your applications in a small memory environment or you're working with very large-scale applications. But because this is a universal issue in Java, it's good to know how to deal with it from the beginning. Java provides two utility classes called String Buffer and String Builder. These two classes have the same API or programming interface, and they both implement the same methods, named insert and append. The insert method can be used to insert text into a string at either the beginning or any other position in the string, and the append method can be used to append text to a string. You can use either the string builder or the string buffer in most environments, but in general, the string builder is more slender. It takes less memory and resources, but it's only good for single-threaded environments. String buffer should be used where you need to synchronize the use of a string among multiple threads. If you're new to Java, don't worry about it. Just use string builder until you find out you have to use string buffer. So here's an example of how you might use string builder. I'm going to take this little bit of code out and leave myself with the simple s1 variable, and then after I've created the initial string, I'll create another variable named string builder. Notice that string builder and string buffer are both members of the package java.lang, so they're always available to your code. So I'll declare the variable string builder and I'll name it sb, and I'll instantiate it using new string builder. I'll place the cursor inside the parentheses and press Control Space and show you the different ways that you can create a string builder. You can either call the constructor method with no arguments or with some of these other settings, but the one I'm going to use is an initial string, and I'll pass in s1. So now my string builder class has been created and it's been populated with that initial value. Now to append a value, I'll call sb.append, and I'll pass in that appended value that I used before, to California. And I'll change my println command to output sb, the string builder. I'll run the application and I get the same result. Whenever you're working with strings that you need to manipulate, either adding text or inserting text, use the string builder class instead of a simple string. You'll create fewer objects and you'll conserve memory.